Guys, good morning, good morning. No, you didn't miss out on much at all. I actually just woke up myself. Actually, not just woke up, but yeah, it was very hard for me to wake up this morning. Why? Because I slept late yesterday, so of course I woke up late, so um, I'm about to kick off. And guys, I'm gonna do grade 12, what is it? Grade 12 trigonometry. Right, so we've done a considerable amount of grade 11, but now today we're gonna do grade 12. But just before I start off on what I'm gonna do here, right, guys, this this guy here, this formula sheet is very helpful. Okay, very helpful. So for instance, in the trigonometry that we are doing, you have some formulas that are provided. Okay, here, this is the compound angle expression for sine, the addition. This is the compound angle for sine, the subtraction. So you have this available in your formula sheet. Okay, these will be provided for you. This is the compound angle for cos, the addition, and then this is the compound angle for sine, for cos as well, the subtraction. Okay, and you can see the expression, how it comes about. Then you have the double angle, the three options for your double angle for cos, and then you have your double angle for sine. So these are in the formula sheet. Alright, so when you write, you must ensure that this formula sheet is next to you so that you can always refer to it whenever you are answering trigonometry questions. Sorry about that. So yes, okay. In as much as it is very good, it actually is very good when you know this off by heart, because when you know it off by heart, it is in your memory bank to be used. But just for verification and to check, you can always refer back to it so that you can be able to make sure that you are always doing the right thing. So hopefully this sort of like recap is a very needful one, and you can see the value of it. Okay. I just wanted to grab my calculator so that it's available for use. I'll put this on the side. Let's come in here. Okay, guys, we have some few questions here. So the very first question says, simplify the following without the use of a calculator. Now I think we've established, guys, that when we say without the use of a calculator, it means that we need to just show our steps, not necessarily that we don't have to use our calculator. We just need to show our steps. So for instance, you can't just put this in your calculator and then write the answer. You wouldn't be able to get the marks that are allotted. So without the use of the calculator does not mean, because someone will just say let me just change my mode here. Would say 2 sine 15, and then they go ahead and they say cos 15, and then they go ahead and they write the answer. That's not what they want. They are saying we shouldn't basically just write down the question, the statement in our calculator and write and get the answer. They want us to show steps. Okay, so the way then we ought to do this question is here, 2 sine 15 cos 15. If you look at this statement, what does it remind you of? Doesn't this remind you of the double angle of sine? Okay, so this here is what you have here. Alright, okay, so this is the expanded form already. This is already the expanded form. So obviously now what we are going to do, we are going to write it in reverse. So that is 2 sine alpha cos alpha is equal to sine 2 alpha. So in other words, 2 sine 15 cos 15 is equal to sine 2 15. This is what they mean by show your steps. Okay, then this is equal to what? Sine of 30 degrees. Okay, And then what you do is you put this in your calculator. Now, you may not necessarily know your special angle triangles, but in grade 11 and 12, it's no problem. Now, at this stage, you can just go to your calculator and say sine of 30 degrees. And then, bam, you've got that answer. The answer is what? It's half. So all that they are checking here is they are checking, can you actually utilize your compound and double angles? So in as much as you are able to expand your your double angles, okay, you must be able to also write them in reverse. So just for those who are joining in, I just looked at 2 sine 15 cos 15. This here should surely remind you of the expansion of the double angle of sine. This is what you would see in your formula sheet. So what you see here is actually this. But the question is saying simplify the following without the use of the calculator. Okay, and so sine 2 alpha is equal to 2 sine alpha cos alpha. So what you then do is you look at this question, you can see it's 2 sine 15 cos 15. Okay, so that means you have to then express this double angle expansion as sine 2 alpha, but in the place of alpha you're going to write sine 2 15 degrees. Okay, are you with me? So from expanded we reduce it, we write this in the reverse. Then what's 2 times 15? It's 30, isn't it? And then sine 30 degrees, this here is what we refer to as a special angle. Okay, and remember special angles, 30 degrees, 45 degrees, 60 degrees. These are all your acute special angles that you've learned in previous grades. Okay, so once again I'm saying sine 215 cos 15, this is the double angle of sine. Remember, in your formula sheet you have sine 2 alpha is equal to 2 sine alpha cos alpha. So if you reduce in reverse, if you write this expanded form in the reduced form, sine 2 alpha, the double angle as per your grade 12 syllabus, this means that this sine 215 cos 15 can be written as sine 2 15 means sine 2 times 15 degrees. Remember, brackets mean multiply. What's 2 times 15? It's 30. So you have sine of 30 degrees. Now sine of 30 degrees is a special angle. So you can take this sine 30. Now you can go ahead. You can put it in your calculator. Say sine of 30, it's equal to half. So indeed, sine 30 degrees is equal to a half. And we had a multiple choice here. They said, simplify the following without the use of the calculator. We're given some options. So is it A, is it B, is it C, is it D? Obviously, you can see we've shown by our working out that indeed the answer is what? Is C. Okay? So our steps are very, very important. Okay? And it's very important to know our double angle expansion. And we need to be able to write our double angle expansion as the single trigonometric ratio, sine 2 alpha, which is what we used here. 2 sine 15 cos 15 can be written as sine 2 times 15, which gives us sine 30 degrees. That is the special angle. And obviously when we take the calculator, put sine 30, we get a half, which is the correct answer. We would get our marks allocated here because we have shown our steps. So this would be important, and obviously that would be important so that we can get our marks allocated to us. Okay, this is grade 12, so that's why this is 2 marks. This is a level 1 question. Why is it a level 1 question? Because it has to do with knowledge. We need to recall something that we have learned, the double angle, and obviously in our formula sheet we can never go wrong. In the formula sheet you have these formulas. You have the double angle for cos, your 3 expressions. You have the double angle for sine, your 1 expression, and then your compound angles for both sine and cos. They are available in your formula sheet. Okay, let's move on to the next question. We are also asked to simplify sine squared 22,5 minus cos squared 22,5. Simplify this. So what does this, look like? Sine squared 22,5 minus cos squared 22,5. It sort of looks like, maybe someone may say, it is the square identity from grade 11. But guys, we know that the square identity from our grade 11 syllabus says sine squared theta plus cos squared theta is equal to 1. So this one is not this, because we have a negative sign in between. So it's not that. It is not that. Then we go to our formula sheet. In our formula sheet, we have the double angle of cos, and there cos squared the alpha minus sine squared of alpha should give us cos 2 alpha. But look here, we have sine squared 22,5 minus cos squared to 22,5. So the only problem here is that cos is not starting, it's only its sine that is starting. But guys, we know for a fact that the subtraction of this is not the same thing as the subtraction of that. This and that are not the same. Alright? So there's something we need to then do. Okay? Some sort of manipulation we have to do. So if we look at this, guys, we're going to use a strategy, a factorization strategy that we call the sign change rule. Okay? It's like a hospital procedure. We say it's called the SCR, sign change rule. In earlier grades, when you had an A minus B like this, and you wanted to change it around, you could take out a negative sign, and then you could write it as B minus A. This is an important strategy, guys. The sign change rule. You change the sign external to A minus B, then you can swap around B minus A. You can swap around A minus B to have B minus A. This negative sign that you have taken out on the outside allows you to change the B and the A around. So if you take this negative and you redistribute it back into this bracket, what's a negative times a positive B? Now you get back your negative B. What's a negative times a negative A? Now you get back your positive A. So basically, by taking out a negative sign, I can swap around the A and the B whilst retaining the negative sign in between. We call this the sign change rule. This is what I'm going to utilize here. I'm going to take out a negative, and then that allows me to write in brackets cos squared 22,5 degrees minus sine squared 22,5 degrees. I've just utilized here my sign change rule. It's a factorization strategy that I use so that I can be able to have that compound expression. It's not the compound expression, but the double angle, expression of cos. So the negative out, cos squared 22,5 minus sine squared 22,5. Then this is actually equal to negative this here. Now if we look at the expansion of the double angle of cos, look at this, cos squared alpha minus sine squared alpha. Now, sorry for the blurriness, I don't know why this usually does this, but yeah, look at this. This can be written back as that. Now I can say cos 2, cos, so it's negative cos 2 times 22,5 degrees. And then what's cos 2 times 22,5? That gives us cos 45 degrees. Cos 2 times 22,5 degrees gives me 45 degrees. But this here is a special angle. Remember, 45 degrees is a special angle. So now I can take my calculator and I can press in cos 45 degrees. That gives me a root 2 over 2. So I know the answer is minus root 2 over 2. There it is, guys. Okay, step by step, simplified. So like I said, sine 22,5 minus cos squared 22,5, because I know that this is not my double angle for cos. I use the sign change rule so that I can get this cos squared 22,5 first minus sine squared 22,5 second. If I take this negative sign and I redistribute negative times, that gives me back the negative cos squared 22,5. Negative times negative sine squared 22,5 gives me back the positive sine squared 22,5. Then this is my double angle expansion for cos. So it's cos 2 times the angle 22,5. Then this here is negative what? What's 22,5 times 2? It's 45 degrees. Then obviously using my calculator, I can then punch this into the calculator. I get the answer negative square root of 2 over 2. Finished. Okay, beautiful, nicely done. Okay, all right, so hopefully we are on the winning page and we are seeing how this is so simple, nice and beautiful. All right, and there's no problems at all. Okay. Okay, Brick Angel. So this was the first question we did. Sine 215, cos 15. This here, sine 215, cos 15, what does this remind you of? If you go to my formula sheet, sine 2 alpha is equal to 2 sine alpha cos alpha. We need to simplify that, what we have there. So this can be written back as sine 2 times alpha. So there we have it. Sine 2 times, not alpha, but 15 degrees. What's 2 times 15? 30 degrees. What's 30 degrees? It's a special angle. So sine of 30 degrees is the special angle. So we can put this in our calculator. We get the numerical value half. Okay. So from the expanded form to the single trigonometric ratio of the double angle of sine, but sine to 15, of course, sine 2 times 15 is 30 degrees, and then the sine of 30 degrees. Because 30 degrees is a special angle, we get a half. Remember that the acute angles that are special, there's 30 degrees, 45 degrees, and 60 degrees. These are special angles. Moving right along to the second question that I just did, sine squared 22,5 minus cos squared 22,5. If we look at this particular expression that's trigonometric, we can see that it kind of, you would think, looks like this, but it's not that. So this is definitely not the same as that. But how do we then manipulate this thing here so that it can mirror the image of that? Okay, so what we do is we use something called the sign change rule. If you are given a minus b, you can write the expression as b minus a. How? By taking out a negative sign. Okay. If there's a negative sign in between two terms and you want to rearrange the term so that you have b minus a, simply take out a negative and write what you have inside in brackets as the order that you had wanted, which was b minus a. If you take the negative sign back into the b, negative times b gives you back the negative b there. Negative times a negative a gives you back the positive a. So this is the sign change rule. We apply the sign change rule here. We take out a negative sign that allows us to write cos squared 22,5 minus sine squared 22,5. Then after that, this negative sign stays outside. This is the expansion of the double angle of cos. As you can see in your formula sheet, cos squared alpha minus sine squared alpha is equal to cos 2 times alpha. So there we have it. We can now write minus cos 2 times 22,5. What's 2 times 22,5? It's 45 degrees. Now cos 45 is a special angle. Remember it was negative, so the answer is negative square root 2 over 2, simply using our calculator. Let's move on. Next question. Sine 331 degrees times cos 179 degrees minus cos of negative 29 times sine 181. Now the first thing when you look at this question, you look at this question and you're like, these angles need to be reduced to what? To acute angles. You can also see that there's sine cos, cos sine, and there's a negative sign. So this kind of says that eventually we will be stepping into the world of our compound angles. Sine cos, cos sine. But we need to reduce the angles that we have there to become our acute angles. So let's go ahead and reduce these angles using our co-function values and our function values. So this here, sine of what? 331 degrees can be written as sine of 360 minus 29 degrees. 360 minus 29 degrees. Okay, how did I get this? I know my function values. I have 360 minus 180 plus and 180 minus. So I look for an appropriate function value that is close to 331, and I can see appropriate function value would be 360. But my question, what is 360 minus what will give me 331? So you can see, if you want, you can go to your calculator and say 360 minus what? 360 minus 331 gives you 29. So the acute angle that needs to be there is 360 minus 29. That's how I got 360 minus 29. And I can say I'm kind of like on point because I can see on the other side, the first angle that starts is 29 degrees. So I'm kind of on point. Let's go and reduce cos 179. Cos of 179, if we use our function value, which function value would be appropriate? 180 plus? No. 180 minus? Yes. 180 minus. The question is, what is the acute angle? If you want the acute angle, just go and say 180 minus 179 so that you can know the angle that is appropriate. It's 1. Okay, so 180 minus 1 degrees. This is an acute angle. Remember, acute angles are angles between 0 and 90 degrees. So that's fine. Go to the minus. Then we need to reduce the negative angle here. Remember, when we have negative angles, what do? We add 360 degrees. So this is like us having 360 minus 29 degrees. We can reduce this, guys, as you see it. 360 minus 29, 360 minus 29. So let's write it down. Cos of 360 minus 29 degrees. We added 360 to the negative 29 degrees. Because this is already acute, I just retain 360 minus 29. Okay? And then last but not least, sine of 181 degrees. Let's reduce this. Sine of 181 degrees, which function value can we use? 180 plus. So we say sine of 180. 180 plus what gives us 181? Plus 1 degrees. Okay. So I would say we are very much on the same, or let me say we are in the right direction so far. Now let us proceed and finish off. Let us now reduce. Remember, 360 minus, which quadrant is this? Okay. Now, you can use this approach, or you can simply utilize and look at this, because you want to reduce and write your reduced version as a trig ratio with your acute angle. The only thing we need to decide is the sign of the trig ratio. So in order to get the sign of the trig ratio, we may as well look at the quadrants, and this is paper 2 grade 12. So this is 180 minus quadrant, this is the 180 plus quadrant, this is the 360 minus quadrant. Why do I know this? 0, 90, 180, 270, 360. Okay, so in our anti-clockwise direction that we are moving in, 0, 90, 180, this here is 180 minus, this here is 180 plus. Okay, and this is 360 minus. So these are the various quadrants that we have. Here, all trig ratios are positive. Here, sine is positive. Here, it is just tan that is positive. And then here, it is cos, that is positive. Okay, so this was the question. Okay, guess those who want to screenshot, this was the question. I just participated in reducing each angle to a acute angle. So I'm now going to apply my reduction using the cast diagram. All right, and I know that all of these, basically, I'm just going to be reducing. This one will be reduced to sine 29 degrees. I just need to determine the sine by using the what? Using the cast diagram. So 360 minus is in which quadrant? It is in the fourth quadrant. In the fourth quadrant, how is sine? Sine in the fourth quadrant is negative. So I know I'm going to put my negative sign there. All right, because with my function values, 360 minus, 180 plus, and 180 minus, only the sign will change. The trig ratio does not change. Okay, yeah. So it's sine 29 degrees. Let's move right along. Cos 180 minus 1. 180 minus is in which quadrant? It is in the second quadrant. How is cos in that quadrant? Cos in that quadrant is also negative. So we write negative cos 1 degrees, followed by the minus sign that's there. Then in brackets, 360 minus is in which quadrant? It is in the fourth quadrant. How is cos there? Cos in that quadrant is positive, times sine 180 plus 1 degrees. 180 plus is in which quadrant? It is in the third quadrant. How is sine there? Sine is negative because only tan is positive. So sine is negative. So we write sine, negative sine 1 degrees. Okay, guys, simply put, okay, you always write the trig with your function values, 360 minus, 180 plus, and 180 minus. It's a matter of writing the trig ratio and the acute angle. And then the sign we need to be able to determine using our cast diagram. But guys, you can also determine the sign by simply typing in all of this. If you've forgotten everything that you need to remember about cast, let's say you somehow forget, you can always just put this into your calculator as it is, so that you can determine what the sign is. You see 360 minus 29, look at this. You see it's a negative answer. Obviously you don't want this. You just want to determine what the sign is. So that's why we say this is negative. You can either use the cast diagram. Sine 360 minus is in the fourth quadrant. How is sine? It is negative. Or you can just punch this into your calculator. The numerical value, you will see the sign from the numerical value. Here we can see it's supposed to be a negative answer. Same thing with cos 181. Cos 180 minus 1. 180 minus 1. Put this in your calculator. You see, you get a negative answer. So that's why we say it's a negative cos 1 degrees. And I'm sure you can repeat the same process so that you can know what the sign of the respective trigonometric ratios are. Please, when you do the reduction, put things in brackets, okay? Now, negative times a negative, we get a positive outcome. So this is sine 29 degrees times cos 1 degrees. We can remove the bracket because a negative times a negative, because this means multiply, the brackets mean multiply. This is sine 29 cos 1 degrees. Okay, then let's come here. Negative times another negative gives us a positive answer. Now we can remove the brackets. Cos 29 sine 1 degrees. Yes, okay. Then we'll look at this. Cos 29, cos 1. Cos 29, sine 1. What does this remind you of? Surely if you go to your formula sheet, you can see sine alpha, cos beta. Cos alpha, sine beta. Okay. The formula sheet is conquering here. Thank goodness. So you checked it out. Okay. And you see, the thing is, it's because I know how it's supposed to be. Because I know it off by heart. Okay. And even this side, this formula sheet was misleading. I don't know why it became misleading. But because we know our formulas off by heart, I know my formulas off by heart, I could see or detect the error. Okay. So this is supposed to be, look at this one. Sine cos, cos sine. 29 1, 29 1. Alpha beta. Sine cos, cos sine. So it is the addition of the sine. So let's go here. We write this as sine in brackets 29 degrees plus 1 degrees. Okay? The signs are the same. Then 29 plus 1. Genie, this can further be written as sine of 30 degrees. Oh wow, this is a special angle. So since this is a special angle, I simply go to my beautiful calculator, guys, and I go and type in that special angle and just get the answer from my calculator. Sine of 30 degrees is equal to a half. So all of that working out, guys, so that I can get the final answer, which is a half. And that's it. Done and dusted. So from reduction of these angles, okay, when I have a negative angle, I add 360, okay, and then you can see this is already acute. So that's why addition of 360 minus that 29, we are looking at the fourth quadrant. Reduce 180 plus 1. So we reduced using our function values. Then we evaluate the sign of each trig ratio. Remember to put things in brackets. Very important. When you evaluate, you put in bracket what you evaluate. It's very important that you do that. Okay. Then after doing that, you then are able to write down the negative times the negative gives you a positive answer. You remove the brackets. The negative times this negative gives you a positive answer. That's why you have a positive there. Then you look which compound expression is this. This is the sine, the addition of sine compound expression. So you add sine 29 plus 1. This gives you 30 degrees. And obviously the sine 30 degrees is a half. Okay. It's just a question paper and Avisita. You guys always ask this question. Which question paper is this? It's a question paper. Okay. What's beautiful about it, it's helping us to be able to use our knowledge that we have gained from the formula sheet. Let's look at this one. 1 minus 2 cos squared 22,5. So how do we reduce 1 minus 2 cos squared 22,5? What does this look like? We go to our formula sheet. In our formula sheet, we can see we have 1, 2, 3. It's not this one. It kind of looks like this one, but the order. Okay, so the fact of the matter is that 2 cos squared alpha minus 1 is not the same thing as 1 minus 2 cos squared alpha. So this and this are not the same. But how do we make this to become the same as that? We apply the sign change rule. So what do we do when I say we apply the sign change rule? We take out a negative, then we rewrite this as cos squared 22,5 degrees minus 1. Take out a negative, then the order 2 cos squared 22,5 can be written first, followed by negative 1. Why did we apply the sign change rule? This is a factorization strategy that allows us to be able to write things in the order when there's a negative sign in between those two terms, in the order that is reversed. So negative times this back gives us back the negative, And then negative times this negative 1 gives us back the positive 1. So in essence, this basically is still retaining its original identity. Now, this here, you can clearly see is the expansion of the double angle cos. This is it. So we say minus in brackets cos 2 times 22.5 degrees. Okay? Yes. And then what's 2 times 22.5? That gives us cos of 45 degrees. But remember, it is negative cos of 45 degrees. What is this? It is the special angle. So we utilize our calculator and we should get negative root 2 over 2. That's it. That's it. So we applied the sign change rule because we could see that the order does not really look like the one that we know. And then after that, we apply the double angle for the bracket. And then we get cos 45 degrees. And this basically is a negative cos 45 degrees. It's a special angle. So we can simply just use our special angle triangles, or we can go ahead and punch this into our calculator. It gives us that answer. Okay, let's do one last one with these reductions. This is grade 12. Sine squared 344, sine squared 345 minus 2. Okay, so first and foremost, let us apply our simplification strategy. Simplification, and I usually talk about this 2-3 important strategy. Simplify, factorize, identity. Simplify, factorize, identity. You look at the first strategy. If it doesn't work, you go on to the next strategy. If it doesn't work, you go on to the next strategy. You look at the first strategy. If it works, you stay there. It works. Then if nothing else works after simplification, you go on to your factorization strategy. If it works, you apply it. After applying the factorization strategy, you go back and you ask, can I simplify? If not, you go on and ask, can you factorize? If not, then you go on and you ask, can you apply a particular identity? This is very important. The SFI 3-part strategy to simplification and solving identities. So let's look at this. 4 sine squared 345 degrees minus 2. Now, this angle needs to be reduced. That's where we start. We reduce the angle. Let us start right there, because this is not a acute angle. So 4 sine squared. Let's reduce this thing. 360 minus what gives me 45? 345. 360 minus 15. Okay. Minus 2. Then, okay, that's still a simplification strategy we are using. So this becomes sine squared. Now, this is something you need to note, guys, that when you have this squared, okay, I'm just going to rewrite this. 4 into sine 360 minus 15 degrees. You take the squared and you actually put it outside the entire trigonometric ratio. So you first then reduce the sine of 360 minus 15. 360 minus 15 is in which quadrant? You ask yourself that question. 360 minus 15 is in the 4th quadrant. How is sine there? Sine is negative. So you write the negative of sine 15 degrees with the square outside the bracket. Now you can apply the square inside the bracket. A even exponent does what to a negative sign, guys? Can someone tell me? An even exponent does what to a negative sign? It makes it positive. So that's why the answer there is 4 sine squared 15. And then obviously the minus 2 follows as per what we had done. Okay? So when we apply the square inside the bracket, we get a positive sine squared 15. That's why in most memos, what you see in the memo, whenever you're looking at the memo for a question like this, you will just see them doing sine squared 360 minus 15, and then straight from this, you will all of a sudden see them writing this step. Okay, because whenever you have an even exponent, whatever outcome you get, whether it's a negative or a positive, you apply the squared, it becomes positive anyways. Okay, so they know that whenever you apply that squared to whatever outcome you get here, it will always be positive. Doesn't matter what it is, because you have an even exponent. Okay, what happened to the negative sign? After evaluating sine 360 minus 15, you get a negative sine 15. But this squared, this is an even exponent. In earlier grades, you learned that when you apply an even exponent to a negative sign, it becomes positive. Okay? Apply an even exponent to a negative sign, it becomes positive. But if you are applying an odd exponent to a negative sign, it keeps the negative sign as it is. So in this situation, we have a even exponent because we have sine squared of the function value. So we write the square outside, we evaluate the function value first, we get a positive outcome when we apply the square to the negative sign. Okay? So that's why we have we are asking, where did the negative sign go? We applied the even exponent to the negative sign. But guys, in your memos, when you are looking at a question paper, a past question paper, and you look at the memo, in the memo they show you this step, and then all of a sudden you see them having this positive answer, and then you ask yourself the question, where did the negative sign go? Because you know when you evaluate this, you get a negative sign. The thing is, this square applied to the negative sign makes your answer become positive. That's why we have a positive sine squared 15. But me, I took the liberty of showing you the step, how to do it, so that you can see, oh, we first take out the square for the trig ratio alone, not for the coefficient, but for the trig ratio. Then you evaluate the function value, you reduce it. You know that sine in this quadrant is negative. You get negative sine 15, but then the square, remember, you have to apply it inside. So you get a positive, because a negative sign, even exponent applied to a negative sign gives you a positive outcome. So that's why the answer is 4 sine squared 15, that is positive. Minus 2 followed. So we are done with the simplification strategy. Now we move on to number 2. We ask, is there any factorization here? Definitely. Highest common factor of 2. You have two terms, you have a highest common factor of 2. What's left inside? 2 sine squared 15 minus 1. Okay, so after simplification, I'm done. Now I apply factorization strategy. Okay, take out the highest common factor, it's 2. I'm left with 2 sine squared 15 minus 1. Okay, is there any further factorization that can be done from here? No. 2. Is there any further factorization that can be done from here? Well, if you go to your what you have in brackets, what does it look like? It sort of looks like this 1 minus 2 sine squared alpha. But is it the same thing? So this is not the same as 2 sine alpha minus 1. This is not the same. This is not the same as that. But the question is, how do we then manipulate this to become like that? We use the factorization strategy called the sign change rule. So what I'm going to do is I'm going to take out a negative sign for the entire bracket. Remember, if I take out this negative sign, it gets multiplied with the 2. The 2 becomes negative. Then it allows me to change the order of 2 sine squared 15 minus 1 to 1 minus 2 sine squared 15. I applied the factorization strategy that we call the sign change rule. Take out a negative, swap the order around, because this was not the double angle expression, but this is 1 minus 2 sine squared 15. So I apply the sign change rule, which is a factorization strategy. Hence I first took out the highest common factor of 2. Additionally, I asked, is there a further factorization that can be done? Yes, the application of the sign change rule, because I can see the identity does not resemble the identity for my double angle, of course. So, because it is 2 sine squared alpha minus 1. I want 1 minus 2 sine squared alpha. So what I do is I take out a negative sign for this expression. That changes the 2 to negative, and then I can change the order. Change the sign, change the order, change the sign, change the order. Whenever you have a negative sign, you can apply this factorization strategy. It's very helpful. Then negative 2 into, now this is the double angle of what? Of course, cos 2 times 15 degrees. What's 2 times 15? I still have negative 2 into cos 30 degrees. What's cos 30 degrees? Oh, of course, that's cos 30 degrees. I can go to my calculator. Cos of 30 degrees gives me root 3 over 2, because it's a special angle. So negative 2 into root 3 over 2. This 2 and this 2, they cancel. And then I'm left with what? Negative times root 3 gives me negative root 3 as the answer. Okay. And this is it. Step by step, guys. Okay. Because here, after applying the factorization strategy, is there any further simplification? No. Any further factorization? No. Identity? Yes. My double angle identity for cos is applied. Then 2 times 15 is 30. What is this? A special angle. So simplification can be done using my special angles. It gives me root 3 over 2, negative 2 times root 3 over 2. Obviously this 2 and this 2, they cancel. I'm left with negative times root 3. The answer is negative root 3. I'm on water. How can someone borrow you a pen? Where are you? How can you be asking here in the platform for this person? You must be kidding me. Okay. Right. So if you want a screenshot, there it is. You can grab it. That's how I did that one. Okay. Guys, with just 4 minutes left for me to be here on this live, right? I'm going to extend it, but just by an additional 5 minutes, right? And then I have to bounce. I have to really leave. Okay. Okay, let's look at these questions. Given cos 44 degrees, use a sketch to calculate the following in terms of A. Do not use a calculator. Given cos 44 is equal to A, use a sketch to calculate the following in terms of A. Do not use a calculator. So we are supposed to evaluate sine 46 degrees using a sketch, but we can't use a calculator to write the following in terms of A. We need to write sine 46 in terms of A. So how do we go about answering these type of questions? We call these the Pythagoras type questions. All right. So we just look at the ratio first and foremost. So the ratio is cos 44 is equal to A. Rewrite this. This is cos 44 degrees is equal to A over 1. Do we remember what the definition of cos is? It is adjacent over hypotenuse. That's in terms of a right angle triangle that you are given. But in terms of your Cartesian plane, it is x over r. Okay, x over r. Very important that you know your trig definitions. Okay, and whenever we forget, we must just remember SOHCAHTOA. Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So cos 44 degrees, we write this as a ratio fraction, A over 1, but we know that this means my x value is a, my r value is 1. So what I do is I draw a Cartesian plane. I know that cos is actually a positive. We can say in that first quadrant, I'm going to have an angle of 44 degrees, right? And then I am going to write, obviously, a right angle. Then I look at my definition. Cos 44 degrees, a over 1. This is adjacent over hypotenuse. So my adjacent side is a, my hypotenuse side is 1. I am missing my opposite side. So I am missing opposite side. In other words, I am missing my y value. So I'm going to use what? Pythagoras, which says r squared is equal to x squared plus y squared. This is Pythagoras. Okay, Charlie the vocalist, ne? We can, there's two things you can do here. You can either, well, the thing is, we know that cos, all right, here a, we just go ahead and assume that it is positive. We are only given this trig ratio. That's the only thing we are given. So we can just say cos 44 is equal to a over 1. Then we can go ahead and assume the first quadrant, because in the first quadrant we know that all trig ratios, it's where all trig ratios are positive. So you have two choices here. You can draw a right angle triangle in the first quadrant, or you can draw a freestanding right angle triangle, which is not necessarily a triangle in any particular quadrant. It's just a freestanding right angle triangle. Okay, so you can just draw a freestanding right angle triangle if you want, with no quadrants. Okay, then obviously you know that's 44. That's the adjacent side, that's the hypotenuse side. Now you need to find the missing side, which is basically your opposite side. So you have two choices. You can either draw a right angle triangle in the first quadrant, or you can draw a freestanding right angle triangle. This is because we are given one statement. We are not given any other additional information. Okay, so basically we can just draw a right angle triangle in our first quadrant, because we are told cos 44 is equal to a. 100%. Now we are missing y, so we use Pythagoras. What is r? My r value is 1. X, my x value is a. Y, I am missing y. Now I have to transpose the a squared over to the other side. So that means 1 minus a squared is equal to y squared. Y squared is isolated. Then what do I do after that? I take the square root, because I want my value of y. When I do that, don't forget to put plus minus, because there are two options or two answers that I could get in that particular quadrant, depending on my y value, if it's positive or negative. But since everything is in the first quadrant, it means I'm going to get a y value that is positive. Therefore, y is equal to the square root of 1 minus a squared. So here I can now populate my y value. In terms of a, it is 1 square root of 1 minus a squared. I leave it like that. Then I usually say to my learners, make sure now that since you have all angles in your triangle, make sure in your triangle you have all angles and all sides. My question is, do I have all the sides? Yes, I have my hypotenuse, I have my adjacent side for 44 degrees, I have my opposite side for square root for y. Do I have all angles? This is 90, this is 44. What am I missing here at the top? I am missing 46 degrees. How do I know this is 46 degrees here? 90, 44, 46. How do I know that that was 46 degrees that was missing? I know it because I know that the angles of a triangle, the sum of the angles of a triangle should give me 180 degrees. So I fill in all the angles. Now I have a complete sketch. It has angles, all three of them. It has sides, all three of them. Now I can come to my question. The question was asking, what is sine of angle 46? Beautiful thing is that this is already an acute angle. And what I'm looking for here is, do I have a 46 degrees in my triangle? You see? So do you see, guys, had I not written the 46 there, then I wouldn't have been able to read the answer from my diagram. That's why I insist that when you sketch your diagram, make sure you have filled in all angles and all the sides. All sides, all three of them, all angles, all three of them. Now, let's go. Sine of 46 degrees. What is sine of 46 degrees? Obviously, the definition of sine is opposite over hypotenuse. So let's go to this angle, 46 degrees, because it is in the diagram. Here is 46. Now, according to this angle, what is the opposite side of angle 46? The opposite side of angle 46, guys, can you see it? It's what? The opposite side of 46 degrees. Not the opposite side of 44, but the opposite side of 46. What is the opposite side of 46? Thank you, water and mad love. It's A. So I'm going to write A over the hypotenuse side is equal to? The hypotenuse side is equal to 1. So therefore my answer, A over 1 is equal to A. Done. Okay, so that's my answer. I replace sine 46 degrees because what did they say? Use the sketch to calculate the following in terms of A. Sine 46 needs to be written in terms of A. So in terms of A, sine 46 is A over 1, which is simplified as A. Right? Let's move on. We are also asked to write cos 88 degrees in terms of A. Cos what? 88. So, first and foremost, when you look at 88 degrees, do I have 88 in my, do I have 88 in my triangle? Okay, do I have, no I don't. But do I have something that sort of like should help me out given my understanding of my grade 12 syllabus, compound or double angles? Cos 88. Can't we rewrite this as cos 2 times 44 degrees? Yes, I think we can. Cos 2 times 44 degrees. This here is my double angle for cos. You see how we draw in the 44 to be there. We use our identity, our double angle identity. Then we can choose from the buffet of expressions for the cos double angle of cos. Which one you choose doesn't matter. You will get the same answer for either one. So me, I'm just going to use 2 cos squared alpha minus 1. So I'm going to write this as 2 cos squared alpha 44 degrees minus 1. Now I can go to my diagram because 2 is 2. In the place of cos squared 44, I'm just going to write a bracket, put the square on the outside, go to my diagram, go and read what cos 44 is. Because this is like saying cos of 44 degrees. And I just put the square outside. Do you see, guys, what I just did here? You see the importance of knowing your stuff. Now let us go replace. What's cos 44? Let's go. Cos 44 is adjacent over hypotenuse. So we're looking at this angle. What is the adjacent side? It is 4. What is the hypotenuse side? It is 1. You are asking, where does the square come from? And I'm explaining this so many times. Cos 244 degrees, all right, is the double angle cos 2 times alpha. Instead of alpha, we have 44 degrees. So now we can use one of 3 of these expressions to expand cos 244. We can use one of 3. So I decided to use 2 cos squared alpha minus 1. So now I'm going to say 2 cos squared 44 degrees minus 1. This is me expanding using the double angle identity. Then I rewrite this 2 cos, this is 44 degrees, but it has a square. So I just wrote cos 44 and put the square outside. because I'm preparing myself to substitute for cos of 44, because that's what I have for my diagram. So I go to cos 44. What is the definition of cos? It is adjacent over hypotenuse. So that means in the place of 44, I substitute a squared minus 1. So the final answer, guys, is 2a squared minus 1. This is cos 88 in terms of a. It is 2a squared minus 1. Guys, I hope you are getting this. It's very beautiful. To me, as I'm actually only tutoring grade 8 to 12, unfortunately. Grade 6, I trust the teachers in that particular level to basically do the things that they're supposed to do with the learners at that stage. Me, I'm a high school specialist. I specialize with the high school kids because it seems like that's where they tend to struggle a lot. So I specialize, I help them out. Okay. Little Zulu saying wants to do rewrites. That's funny. Okay, guys, I'm going to do this last one. All right. Then tomorrow morning I will pick up from this stage. We are going to do these types of questions. Pythagoras type for this question. So I'm doing the last question because the Maths is a game host. It needs to end the live and go to work. I have learners I have to attend to. So sine 22 degrees. All right. We need to write this in terms of a as well. Now I'm sure some of you are looking at this and you are like, all right, what is happening here? Sine of 22 degrees. What time tomorrow? Same time, guys. 5 a.m. That's what we shoot for. Like last night, unfortunately, I slept very late because I was kept up by the grade 11s. I slept early hours of this morning, actually, because the grade 11s kept me up the whole night. And I woke up basically a bit late. So I started the live at 5:30. So we can shoot for that time. Okay, we'll shoot for 5, but guys, push comes to shove, I'll start the live at 5:30 tomorrow morning. But let's shoot for 5 a.m. because that is the goal. Wake up early so that we can tackle these things early. I can do more if I start at 5 o'clock, but I do less when I start late. So sine 22 degrees. Any ideas, guys? Because remember, we need to write this in terms of a. But in our a values, we only have 44 and 46. So what do we do here? Charlie the vocalist. That's very kind of you. You're very generous. Your comments are very generous. I accept and I appreciate. But be live at my school, I cannot. I can't be live at my school, unfortunately, guys. I can't. That's the unfortunate part. Okay. So someone is saying, but sir, that's half the angle. Okay. Right. It is. But then I have to somehow be able to get it to a place where I can actually utilize sine 44. So, you know what? I really have to go, guys. I am going to leave you guys to basically figure this one out. So tomorrow morning when I start the live, because I am really pressed for time, all right? If I don't leave now, I will be late, and I can't be late on Monday, guys. I have assembly and stuff. So I'll leave this one, okay? It's a level 3 type question, which means, in other words, it needs what? It's a complex procedure. It needs a bit of brain mass, brain juice. But this brain juice can be made easy when we understand what we ought to do. So I'm going to leave this one. You need to write this in terms of a. Just for those who are coming in now, this was our diagram that we basically were able to form using cos 44 is equal to a. So here it is, there it there. Okay. Good people, I'm going to love and leave you. I'll see you tomorrow. Thank you so much for joining. It was really a joy for me to help you out. Please take care of yourself and have a great Monday. God bless all of you. And let's do the maths, guys. If we do the maths, it will become easier to do, and we will be able to get the levels that we want. Cheers, guys.